Hello everyone, welcome to this video lecture of Engineering Hydrology. This is Sukamal Ghosh, Assistant Professor, Civil Engineering Department, Greater Kolkata College of Engineering and Management, JIS Group. In this particular video, we are going to discuss about infiltration and what are the various factors that affects the infiltration. So when the precipitation occurs at the time T equals to 0, that precipitation will not going to contribute the runoff because most of the time the soil at the ground is dry and hence it will absorb the precipitate water. So this movement or the flow of water through the soil is known as infiltration. So soil will absorb the water till it reaches its maximum capacity. It means the infiltration process will continue until the soil reaches to its maximum saturation capacity or the field capacity. Now after reaching the maximum saturation capacity, the extra water that flows through the soil will be known as the percolated water, and this percolated water ultimately reaches to the groundwater table as shown in this particular picture. Okay. Now, other than the infiltrated and percolated water, the remaining precipitation or the precipitated water will contribute to the runoff. Okay. Now, so when the water is applied at the surface of a soil, 4 moisture zones in the soil as shown in this particular figure can be identified. In the infiltration process, at the very top, a thin layer of saturated zone is created. You may observe in this particular figure, at the very top there is a saturation zone. Now beneath the saturation zone we have the transition zone. Okay. Now the next zone lower to this transition zone is the transmission zone, where the downward motion of the moisture takes place. Okay. Now in the transmission zone, the moisture content is above the field capacity but below the saturation. Okay. So let me write it here. In the transmission zone, the moisture content, suppose we denote the moisture content by MC, then the MC is above the field capacity. Okay. So it is more than the field capacity. But also the moisture content is less than the saturation. Okay, in transmission zone. Now further, the transmission zone is characterized by unsaturated flow and fairly uniform moisture content. Okay. Now our last zone is the waiting zone. You can see here, this is our last zone which is called as waiting zone. Now the soil moisture in the waiting zone is nearly equal to the field capacity. Okay, and the moisture content decreases with the depth. Okay, so let me write it here. In the waiting zone, the moisture content is nearly equal to the field capacity. Okay. And from this particular figure, you may observe that with the increase of the depth, the value of the moisture content is decreasing. Okay. And the boundary of the waiting zone is known as waiting front, where a sharp discontinuity exists between the newly wet soil and original moisture content of the soil. Okay. Now depending upon the amount of infiltration and the physical properties of the soil, the waiting front can be extended from few centimeters to meters. Okay. So this waiting front can be extended from few centimeter to meter. Okay. And this extension is depends upon the infiltration and the physical property of the soil. So this is all about the distribution of soil moisture in the process of infiltration. Okay. Now, so the infiltration process can easily be understood through a simple analogy. Okay. If we consider this small container which is covered with the wire gauge, and if we pour some amount of water into this container, then a part of this water will go into the container and a part of this water overflows. Okay. So this is the overflowed water. Okay. This is the overflow, and this is the part of water that is going into the container. Okay. And this is the amount of water which we pour into the container. Okay. Now further, the container can hold only a fixed quantity of water, and when it is full, no more flow into the container can take place. Now while this analogy is highly simplified, it underscores two important aspects. The first one is the infiltration capacity, which means the maximum rate at which the ground can absorb the water, and the second one is the field capacity. Okay, which means the volume of water that the ground can hold. Now if you consider a high intensity rainfall and a low intensity rainfall, then you may find a high intensity rainfall will contribute to the groundwater flow, but a low intensity rainfall does not contribute to the groundwater flow. This is because when a high intensity of rainfall occurs, it contributes to the infiltration first, and since the intensity of rainfall is high, the soil reaches to its maximum capacity easily. Now after reaching the maximum field capacity, there may be more amount of water remains in high intensity of rainfall, which may percolate and ultimately contributes to the groundwater flow. You can see here the high intensity of rainfall initially contributes to the infiltration. Okay, this is the infiltration. You can see here, and due to the high intensity of rainfall, the soil easily reaches to the maximum field capacity or the maximum soil moisture storage capacity, and even after reaching the maximum storage capacity, there is some amount of water remains in the case of high intensity of rainfall, and that remaining water percolate to the groundwater, and that is how the high intensity of rainfall contributes to the groundwater flow. But on the contrary, for the low intensity rainfall do not has the ability to saturate the soil fully. Even if it saturate the soil fully, then there may be no water remains which can contribute to the groundwater flow. You can see here, this is the low intensity of rainfall, and after contributing to the infiltration, it is very difficult for the low intensity rainfall to reach the field capacity. You can see here, this is the maximum soil moisture storage capacity or the field capacity, but due to the low intensity of rainfall, the moisture is able to achieve only this amount of depth, which is not even equal to the maximum soil moisture storage capacity or the field capacity. But even if it reaches to the maximum soil moisture storage capacity or the field capacity, it will not have any more amount of water which can contribute to the groundwater flow, and that is why the low intensity of rainfall do not contribute to the groundwater flow. Okay, now apart from the groundwater flow, the high intensity rainfall also contributes to the surface runoff. Okay, but the low intensity rainfall does not contribute to the surface runoff as well. Now we are going to discuss about the infiltration capacity. So what is this infiltration capacity? The infiltration capacity is the maximum rate at which a given soil and at a given time can absorb water. It means the infiltration capacity is the maximum absorption rate of a given soil at a given time. And the infiltration capacity can be designated by the F suffix P. And the unit of the infiltration capacity is centimeter per hour or millimeter per hour or millimeter per second, etc. Okay. Now there is a relation between the intensity of rainfall, the actual rate of infiltration, and the infiltration capacity. So when the intensity of rainfall, which is designated by I, is more or equal to the infiltration capacity, the actual rate of infiltration, that is F, will be equal to the infiltration capacity. Okay. On the other hand, if the intensity of rainfall is less than the infiltration capacity, then the actual rate of infiltration, that is F, will be equal to the intensity of rainfall, that is I. Okay. See, it has been written over here that I is the intensity of rainfall and F is the actual rate of infiltration. Okay. See, this will be suffix P. Okay. This will be F suffix P. Now, so what are the factors that affects the infiltration capacity? There are various factors which can affect the infiltration capacity, such as the characteristics of soil, then the impact of raindrop, then the temperature, the vegetation cover, and the fluid characteristics. Okay. So let's discuss all the factors one by one. Okay. So the first factor that affects the infiltration capacity is the characteristics of the soil. So the type of soil, such as whether it is sand, silt or clay, and their various characteristics like texture, structure, permeability and the under drainage affects the infiltration capacity. So a loose permeable sandy soil will have a higher infiltration capacity than a tight clay soil. This is because the permeability of sandy soil is higher compared to a tight clay soil. It means more the permeability of soil, more the infiltration capacity. Okay. Now also a soil with good under drainage. Under drainage means the facility to transmit the infiltrated water downward to a groundwater storage. Okay. So a soil with good under drainage will obviously have a higher infiltration capacity, right? Also, a dry soil can absorb more water than one whose pores are already full. It means the dry soil has more infiltration capacity than a moist or a saturated soil. Okay, this is obvious because the pores of the saturated soil is already full with the water. So there is no space available so that the extra amount of water can infiltrate. Okay. Now apart from that, the land use has a significant influence on the infiltration capacity. For example, a forest soil which is rich in organic matter will have a higher value of infiltration capacity under the identical condition than the same soil in an urban area where it is subjected to the compaction. It means the degree of compaction also affects the infiltration capacity. If the degree of compaction is higher in a particular soil, then the porousness of that particular soil is less, and if the porousness of a particular soil is less, that indicates the permeability of that soil is also less. And if the permeability of the soil is less, then obviously the infiltration capacity is also less. Okay, so we can also write that if the degree of compaction is higher, then the infiltration capacity Fp is lower. Okay, now this figure shows the variation of infiltration capacity for different type of soil. Okay, so this is the infiltration capacity rate with the time of the wet clay loam, and this is the infiltration capacity rate with the time for dry clay loam. So as we discussed, the dry soil will have more infiltration capacity because it can absorb more amount of water than the wet soil, right? In this way, we can plot the infiltration capacity with the time for different type of soils. Okay, now how the raindrop impact the infiltration capacity? See, if the impact of raindrop is more, less the amount of infiltration, and vice versa. Actually, the impact of raindrop leads the dispersion of soil, or you can say the impact of raindrop causes the displacement of the soil. This in turn can clog the pores in the upper layer of the soil, and thus the infiltration capacity decreases. Okay, because if the pores get clogged by the displaced soil, then the water cannot move through the soil, and thus the infiltration capacity of the ground decreases. Okay, now also the infiltration capacity increases with the atmospheric temperature. See, actually you may observe that in the summer, due to high temperature, the soil becomes dry, and once the soil becomes dry, the absorption capacity of the soil increases, and that is why the infiltration capacity increases. And that is why in the summer season, due to the high temperature, the infiltration capacity increases. But in the winter season, due to low temperature, the dryness of soil is less compared to the summer season, and that is why infiltration capacity is less at winter. Okay, apart from that, a surface covered with grass and the other vegetation increases the infiltration capacity. Okay, see, the vegetation cover increases the infiltration capacity due to two reasons. The first one is the surface covered with the grass and other vegetation reduces the impact of the raindrop. Okay, so basically the vegetation cover reduces the impact of raindrop. Okay, and thus as a result the infiltration capacity increases, because here we have discussed that less the impact of raindrop, more the infiltration capacity. Okay, also the roots of the vegetation make the soil porous, and thus the permeability of soil increases, and as a result infiltration capacity increases. Okay, so let me write it here. The roots of the vegetation make the soil porous. Okay, and thus the permeability of soil increases. Okay, and if the permeability of soil increases, then obviously the infiltration capacity will also increases. Okay, now last but not the least is fluid characteristics. So the water infiltrating into the soil will have many impurities. Okay, and these impurities are both in solution form or in suspension. The turbidity of water, especially the clay and the colloid content, is a very important factor which affects the infiltration capacity, because Such suspended particles blocks the fine pores of the soil, and thus it reduces the porousness of the soil, and as a result the permeability of soil decreases. And we know if the permeability of soil decreases, then infiltration capacity will also decreases. Okay. Now in fluid characteristics, apart from that, the contamination of water by dissolved salt may affect the soil structure and in turn affect the infiltration rate. Okay. So this is it for today. In our next lecture, we will discuss how can we measure the infiltration. Till then, stay safe and stay happy. Thank you.